Hello, I'm Homer Kraut. We're going to spend the next few minutes talking about world-class business and tools for saving time. We'll take a look at time as a resource, toolbox and shadow board systems. We'll spend a few minutes talking about early warning systems. We'll discuss task flow, and then we'll look at some additional measures that you can use for saving time. First, time is a resource. This is an easy issue to overlook as you begin working on a project or you're working in a business, and it's an area that's most critical as you move towards the completion of a particular product. Time equals money. Managing time results in saving dollars, but is one of those resources that slips away fairly easily. You need to pay particular attention to it. Any time that you save on an individual process ultimately winds in an accumulative saving of time in the long run. Time saving is cumulative. Some of the questions that you should be asking yourself at this point is, how can I measure time more efficiently for whatever process or product or end result that you're involved in? However, you should not get to the point of diminishing returns as you begin to look at time and time savings. At some point, you're wasting time trying to save time. Okay. Toolboxes and shadow box systems. These are simple but very, very efficient systems. They are a good example of simplicity based on efficiency. They are adaptable to multiple uses, and they are particularly good as applied to tool-based operations. Tools should have a purpose and a place. The concept sounds simple, but it's often overlooked as we attempt to improve business processes. What you need to do is to develop a system that will identify and locate all tools. Systems aid in locating tools and identifying those that need maintenance. Evaluating and looking at a system in general allows you to focus on the individual parts, how those parts contribute to the system overall, and provides a foundation on which you can improve the overall system by improving the individual parts of the system itself. This is an example of a toolbox. Is there anything missing? Most of us have experience with tools or items thrown together in a toolbox. The concept of a box in which to place tools, unless examined in some detail, usually results in a container that is somewhat jumbled in terms of contents. This is a shadow board. Is there anything missing here? You should be able to look at this particular diagram and immediately see that there is a tool missing and where it goes. What we've done is taken the same set of tools out of the toolbox, placed them on a large board or a wall, defined each place that the tool is placed on the board, and it only takes a glance to notice that a tool is missing. Toolbox and shadow systems example. What we've done is we've taken the toolbox and the shadow board. Toolbox is on the left, shadow board is on the right. What tool is missing from the toolbox? What tool is missing from the tool board or from the shadow board? Which way would you prefer? This is a good summary example of toolboxes and shadow boards. A question that you might consider asking yourself is, if you were looking for an organization or an individual to support your operation and you walked into their shop and you immediately looked up and saw a shadow board or a collection of tools in a toolbox, which would you prefer, at least on an initial inspection, to work for your company or produce a product for you? All right, we now take a look at early warning systems. Early warning systems provide alerts for an operation, allow you to see if a tool or a system is functioning or operating satisfactorily, allows you to see if a system is malfunctioning, and allows you to identify a process that may have stopped or ended. Most of you are already familiar with early warning systems. Gas gauge on a car, flickering of a light bulb, yellow on a traffic stop that most of us are aware of that we should stop for, blue lights on a police vehicle, a thermometer, elevator lights, fire alarms. These are all examples of early warning systems. What we are trying to do is to apply the same concept to a work or a business process environment. Here's a question for you. Would you consider a watch as or part of an early warning system? Some additional questions that early warning systems assist you in getting answers for. Is it operating efficiently? What has the potential for causing a malfunction? Can we manage the potential for a malfunction? What will or is causing a process to stop, or do we need it to stop? In future lessons, we will be discussing brainstorming, and brainstorming is a good way to address these particular issues as you move forward in a manufacturing or a business process. Early warning systems. In the next few slides, we are going to take a look at some good examples of early warning systems. Example number one. Take a look at the screen. We have a warning light that tells you if the coil is going to run out. This is a coil of rolled steel. There's a sensor here that looks at the steel as it comes off the roll. We have a press that does something to the steel. We have a light here that indicates whether the press is functioning or not. We have a pallet on which the output of the product is placed. And then we have some sort of a light here or a sensor that tells us when our output product has matched the requirements. There are 3 warning lights here. The first lets you know if the coiled steel roll is running or has run out. The second lets you know if the press is functioning. The third light indicates that the batch is complete or if the process is not functioning at all. Some questions that you should be asking about this. If you were involved in this process, you should be asking as to why do we have warning lights? Why have we placed them where they're placed? What process does it protect? In the case of the coil light, the warning light, is it protecting the coil or is it protecting the press? What happens if you allow a process to continue in a case of a malfunction? Those are questions that you should be asking. Example number 2 is the early warning systems of a hopper. This is a very typical system in a system that has some sort of a flow product. It could be corn, it could be wheat, it could be a liquid. Please note that there's a sensor that talks about how full the light system is. There is a low-level warning light, there is a product, and there probably should be in this particular example some sort of sensor that looks at output flow at the bottom of the funnel. This is an example that can easily be adapted to other products. This is a third example of an early warning system. Essentially, we have a container or a tank that has a fluid in it. We have a low-level sensor, a low-level warning light, a flow control valve, and what you should be asking is, are you familiar with common systems like this? This actually follows the same process that a fuel tank does in a vehicle. The low-level sensor detects the presence or absence of fuel, and that's translated into a gauge on your dashboard that tells you whether you have a full tank or an empty tank. The low light level is generally also transmitted in terms of data to your fuel gauge, and as it gets lower, sometimes you have a warning light that comes on that tells you that you're about to run out of fuel. The flow control in this particular diagram is synonymous with a gas pedal. So what you're doing is controlling the flow of fuel in the example that I'm using, controlling the flow of the fuel as it goes to the engine of the car. It's an interesting concept, and it has a number of applications. Okay, now we're going to take a look at task flow. Some of the same principles in early warning systems apply to the task flow environment. Some questions that you should be asking yourself up front: how can I improve the efficiency of a process or a task involved in a process? Can I improve safety? Sometimes we forget about the safety aspects as we're trying to improve a task. One of the things that you should always keep in mind is it safe, not safe? What can I do to improve safety? Task flow is one of those systems or one of those processes that should be addressed and analyzed as both a system and an individual process within a system. As we move through this series of lessons, again, I will talk a number of times about systems and the individual parts of a system. You have to look at both a system and the parts to ensure that they're functioning correctly. Arrange tasks logically. Review tasks, tools, and equipment for logic sequence. When you review tasks, make sure that you review them as part of the whole system. If you look at the task out of context of the system, the potential is that you will make mistakes. Almost every process has some logic as to how tasks are put together, how they start and stop. It may be that over time, the logic is either no longer valid or it can be tweaked to improve the process or to improve the tasks and the task flow. Some basic considerations here. What you're doing is taking a raw material in general and collecting it and processing it to develop or complete a final product. You generally need to know the quality of your final product in order to know the quantity of the raw product that you'll need. And it's necessary to have some general idea of the sequence of events that will move you from raw product to final product. When you look at tasks, you should ask yourself a number of questions. Are they sequenced for efficiency? Can equipment be moved or adjusted to increase the efficiency of the operation that the equipment is performing? Again, you need to review and evaluate both the task as part of a system and as individual tasks to ensure that, or to try to improve the process. The next two slides we'll look at a before and after logical task function. Logical task function, this is an example of before. This is a coiler. It's not important to understand what the coiler in this particular case is doing, but you need to look at the process and the steps in the process. What we have done, we've got two areas of flow. We've got two coil stores, if you will. We have two decoilers, and we have staffing for two people. The flow in this particular case is somewhat disjointed. We have two flows that go from the bottom of the screen to the top, and one flow that comes from the top of the screen back to from the coil store to the coiler. Now the next slide is going to look at this example after a change in the process. Notice that what we've done is we have flow moving in a continual logic direction. Flow comes down, it comes across, and it comes up. We have one example of a coil store. We have one example of a decoiler. We have one area in which the material off of the coiler is processed. We have one coiler. We have an additional decoiler through the coil store. We have a rolling press, and we have an outfeed table. Note down here that from a staffing, we have gone from 2 personnel to 1. Let's go back to the other slide very quickly. Again, note the efficiency that we've made in the before and the after process. This particular process is difficult to read as it stands. As you work through it to the new process, this is infinitely easier to see and understand. Some notes here. If you are going to lose or reduce the number of people overall as you work through task efficiency and operation, this needs to be considered separately as a concept. There is always turmoil when you reduce the number of people that work for you. So in this particular case, improving the operation reduces the number of people. Not to say that you can't move that individual to another place and use them in a different process or a different operation, but it's a point that you should consider. Additional measures. Let's take a look at some additional measures that you can use to improve processes and operations. Consider the marking of all gauges. Mark type, flow, and direction. Marking should be simple, logical, and repeatable. And where possible, use an international standard set of markings. If you're going to mark equipment or an end product, it would be best to mark it in such a manner that other people can read it if the product is marketed internationally. Examples of these already exist in your particular world. One-way streets, highway direction signs, direction markers, and if you've done a little traveling, you'll note that most direction markings on highways and in cities are based on an international standard. This is the type of marking that you should attempt to make or attempt to use in developing your products. Let's look at some common industrial markings. First example, The arrows indicate flow direction, and the color in this particular case indicates hot contents. What we have is some sort of a pipe with some sort of contents that are hot. We assume that they're under pressure because there's a pressure gauge here. Now the pressure does not have to be a lot, but the assumption is, as I look at this, that this is under pressure. And we have an output, and the output is also hot. It may or may not be under pressure, depending on the process that takes place behind this pressure gauge. This is very typical of markings in an industrial plant. If I saw this in a plant, I would assume that this is a high pressure steam system. That may or may not be correct. It could be a hot liquid under pressure, may or may not be steam. It could be a flammable liquid like gasoline. It could be a corrosive liquid like chlorine. Now, I would note that in general, the color red indicates contents that are hot. There are other colors that are used to indicate whether colors are corrosive, whether it's a flammable liquid, and generally they are marked in different manners. It also could be water. It could be high pressure water that comes through that's under some sort of a temperature, maybe a high temperature hot water bath that comes through. Example number 2. This is a very, very common device that we see on streets and in highways. And it's an interesting one because what I'm going to tell you is not what you would guess when you first look at it. One of these is a high volume, low pressure outlet. And there are 2 high pressure outlets, which is not what you would find in a typical fire hydrant on a street. This delivers the same liquid now, in this particular case it's water, at both high and low pressures. As I look at this, I would assume that the smaller of the outlets is high pressure. I would also assume that the bigger of the outlets is low pressure, but I actually don't know by looking at this. And unfortunately, if you're in a hurry, you could mistake one for the other. Although admittedly, with couplings of different sizes, it does tend to only allow coupling of one size. This is how this should look. Okay? We have high pressure on the left, high pressure on the right, and a low pressure here. This particular device has 2 and sometimes 3 feeds that are come up through the bottom. These are extremely high pressure. This is used for high pressure washing. This is actually used for low pressure water feed. We'll take just a short look at floor and storage layout. What you need to do is to consider labeling storage areas. Any place that you put materials, supplies, repair parts should be clearly labeled and they should be accessible. You should put those materials that are needed immediately in one area, and then you should put those materials that are not necessarily needed in another area. There should be layout and flow considered for this, and it should be efficient. You shouldn't have to spend 15 or 20 minutes looking for a part that you use on a daily basis. It should be located up front. Now that does not always allow for parts to be put in either a numerical or a logic order, but they should be put in a functional order. If your business works on a JIT, a just-in-time processes, then what you need to do is to make sure that those things that you need are labeled and placed where you can get to them fairly easily. Marking out flow patterns for walking. This is an area that we don't consider very much, but we should. We have one-way elevators and escalators. we have one-way walkways, but a lot of times in warehousing we forget that we should mark patterns for moving in and moving out of those particular areas. We need to mark the flow patterns. If we consider the labeling and storage areas, what we need to do is to mark flow into and out of those areas so that we can get to those materials in an efficient and timely manner. Path arrows for forklifts and other machinery. Up to this point, we've really talked mostly about walking. Now that we've thrown mechanical equipment into this, we really need to spend time looking at flow, looking at marking, looking at how we move into an area and out of an area, both from a personnel perspective and from an equipment perspective. Sometimes it's difficult and sometimes it's necessary for us to have both people and machinery moving in different directions at the same time in a process. Think of an airport. Machinery is not allowed to drive through or across an airport when aircraft are moving. However, if you look around the periphery of an airport, you will find buses, taxis, delivery systems delivering food to your aircraft. So there are ways that this is done. And airports in particular are a good example of paths that have been laid out for machinery. This same type of thought process should be used as you lay out information and flows for your areas. In and out marking for doors. This is an area that we tend to forget and that we don't do all the time very well. Where there is a high volume of traffic, there's a high volume of machinery, then it's critical that we ensure that what is coming in does not meet what is coming out. We need to make sure that what we set up and what we design is safe and efficient. In short, any labeling for saving time or improving efficiency should be considered. We've spent the last few minutes talking about time as a resource. Time is one of those things that you cannot allow slip by you. You need to spend time looking at time in both the sense of, can you save time? Can you improve time? Time generally in a manufacturing process translates into money. We took a look at toolboxes and shadowboard systems. These systems are an easy way for a company that has a tool-based operation to look at, see, and identify tools that are present or absent where a needed tool is, and it allows you to look at tools in terms of, do they need maintenance? They're very visible. It's very easy to see if they have been treated badly or if they need repair. We looked at early warning systems in the sense that, how do you indicate where a process needs to be improved or whether there may be a problem? We look at flow into a process. We look at checking on raw materials as it comes in. We look at flow through a process. We look at the process itself to see if there is an indicator that needs to be placed so that we can see what is going wrong or not going wrong with a process. Good examples, as I noted before, of an early warning system: traffic lights, police lights on a car, and those kinds of things. We looked at logical task arrangement and talked about how we could arrange tasks. And again, tasks should be addressed as part of a system. You should look at the system itself, what is happening. You should look at the individual parts, and then you should look at how you can improve the system based on improvisation or improving the individual tasks. And finally, we looked at some additional measures. There are some questions that you really should be asking yourself at this point based on this particular lesson. This has been an overview. What you should ask yourself, are there additional ways to make efficient use of time? Stop, take a look at what you're doing, take a look at your manufacturing processes. If you go to look at a process, just take your time and look around and say, is there a way that we can improve this in terms of time? Now again, make sure that it's not redundant. There's a point at which you start improving time and it's a waste. So you look at a process and say, can I improve it in terms of time? There's a corollary to this though. Do I need more time or less time to make a process more efficient? If a process takes 10 minutes, for example, and you look at it and you say, if I take 15 minutes for this process, I will have a better product. Then it may be that when you look at saving time, that you've increased the amount of time. Again, it's a question that you should be asking. Anytime that you look at the business that you're in, you say, can I save time? Do I need to save time? Or do I need more time? Remember, time translates into money. Another question that you should ask yourself is, what kind of early warning systems do I need? Sometimes I think that having a traffic light on every corner is kind of sort of redundant. Somebody has decided that that's the kind of early warning system we need, and in the numbers that are there. When you look at your process, what you need to determine is, do I have places that need early warning? Then you need to decide, are they critical or are they non-critical? As you explore that in early warning system, there's always a price associated with that. So you need to determine, yes, I need this particular early warning, or no, I do not. If I elect not to implement this particular early warning, what is it going to cost me in terms of time, in terms of material, in terms of production quality, in terms of information? Can I afford to put in non-critical warning systems? It's an issue that you have to discuss with your company and with your management and your boss. But again, that's a kind of question that you should be asking yourself. Think back on this particular lecture. We've talked about most of these issues as part of a system. And as we move through this particular area, I will always talk about systems and individual parts of a system. Are there ways to make your system better by focusing on the efficiency of tasks? Thank you for your time. If you need additional information, please consult the current website.